7-7 is now bringing decimal points into our problems. So 0.6, remember, is less than 1. That's 6/10 and 80. In this case, it doesn't make any difference that the bigger number is on the bottom. It's still going to be a kind of a mental math problem. Now, a lot of you, when there's a 0 here, you'll multiply 0 times 6 is 0, 0 times 0 is 0, and then you'll say, oh, I'm going to forget about that 0, put in a 0 as a placeholder, and finish the problem out that way, which is fine. When you add it together, you're going to get 480. Up here, we went over one place value. This went over no place values. So in my answer, I need to go over 1, which means I need to have a decimal point here, which is the same thing as saying 48. But because we have a decimal point in the problem, we can leave that decimal point like that. But instead of doing this every time, if you're multiplying by 0, you know you're going to get 0. It's a property of 0. So you can just skip right to this step here, and you can say, okay, I'm done with that because I know I'm going to get 0. So I'm just going to add in my 0 as a placeholder and then finish the problem out this way. This went over 2 place values. This did not go over any. So my answer has to go over 2. 1, 2. I need to put a decimal point right there. Now I'm going to get rid of that, and I can get rid of this 0 too if I want to, and my final answer is 3.5. Even though number 14, they're two 3-digit numbers, the process is exactly the same. We're going to multiply our ones place first. I'm going to get rid of that so I don't get confused. I'm done with this. I'm going to add in my 0 as a placeholder. I'm going to multiply my tens place now. Erase that so I don't get confused. I'm done with this, so I need to add in 2 placeholders. And I have 5 times 1, 5 times 2, 5 times 7 plus 1. Nice and neat. Add this together, 16, 12, 13, 8, 9, 3. This went over 3 place values. This did not go over at all. So this one needs to go over 3. So I count over 1, 2, 3, and my decimal point goes right there. Number 16 is just filling out a chart. There are 7 days in a week, and this is showing how much they run each day. So we're multiplying 7 times 0.6 or 6/10. So I can do my work. I'm going to do my work off to the side over here. And I have this one over 0, this one over 1. So this is going to go over 4.2. So he ran 4.2 miles. This is great for if you're checking to see if an answer makes sense, because if you forgot the decimal point, it doesn't make sense that somebody would have run 42 miles in a week when they didn't even run a full mile in a day. Now, there are 30 days in April, so now if we're still talking about days, we're not talking about weeks, so we're going to take this 0.6 again, and off to the side, I'm going to do my work. And I get 18, and again, it went over 1 decimal point, and so I have 18 miles in April. So Shannon's going to do the same thing. Shannon has 7 days in a week times 2.4 miles, and then 30 days in April times 2.4 miles. Now here, when you do the problem, she's running over 2 miles a day. So you know your answer is going to be over 14. So if your decimal point's in the wrong spot, you'll know because it should be right around 14, a little bit over 14 for miles per week. And you know if you multiply 30 times 2, you get 60. So she's running more than 60 miles in April. Number 17, it's just asking you to think through mathematically. If May has 1 more day, April had 30 days and May has 31 days. So all they would have to do to find out how far each runner will run during May is add to what they had up here. So if in April, for example, Cedric ran 18 miles, in May he's going to run 1 more day. So we just need to add, and this is going back to the beginning of the year, we need to add these together. And right now you can see already I made a mistake because I was thinking multiplication. When we add, we need to line up our decimal points, and this really truly should have just been mental math. That is incorrect. We know that it's going to be 18.6 because there's 1 extra day in May. We just looked at this 2 days ago. Remember, a straight angle is a straight line, 180 degrees. So our straight angle here is right here, a straight line. So our angle is angle EGH. Our right angle is 90 degrees, and again, they should have labeled this because this could possibly be 89 degrees, but it isn't. Remember, our vertex has to be our middle letter, so we have A, B, C. Complementary angles are angles that equal 90 degrees. So that's this right here. We have to label this angle and this angle. A pair needs to be 2. The supplementary is 180 degrees, so we need to label this angle and then this angle. So remember, a pair means there needs to be 2 angles listed.